So I ran my first half marathon today, and it wasn't fast. I was just happy to finish. But I was running it with a good buddy of mine that runs marathons at speed. And he came up with a really interesting math problem. He said, as runners, we tend to start out with our quickest pace in the first mile, and then that pace uh, is going to deteriorate every single mile. Now, let's say that we lose about 2% of our pace every single mile, or basically it takes 2% longer to run that next mile as your previous. So, how fast does my beginning pace have to be so that I could finish a half marathon in an hour and a half? So, in order to figure that out, what we're going to say is that X is going to be this, this beginning pace. Now, I know that my pace is going to, it's going to take me 2% longer to run this than the previous one. So the next one is going to be 1.02 times X. Now, it's going to take 2% longer for the next one, but not 2% longer of the original, 2% longer of my new pace. So the next pace is going to be, 1.02, so 102% of, or multiplied by, that 1.02 times X, that previous pace. Which also means that the next one is going to be 1.02 times, what we had before. This is 1.02 times 1.02 times X. And we can kind of see that there's a pattern here. So the first mile is just 1 times X. The second mile, I'm going to need one factor of this 1.02. The third mile, I'm going to need 2 of them. The fourth, I'm going to need 3 of them. And what I could do is I could write these as powers. So plus, next one, I'm going to need 4 of them. So 1.02 to the fourth, 4 factors of this. Plus the next one's going to be 1.02 to the fifth times X, all the way up to, what we know we're going to go is we're going to get to 13. Well, I know it's 13.1. Let's just stop at 13 to make this, nice for us. So this is going to be 1.02. Now, not to the 13th, but to the 12 times X, because remember this is mile 1, this is mile 2, which only needed 1 factor. Mile 3 needed 2, so this power is going to be 1 less than what we had before. And what I need this thing to be equal to is, I want to do it in an hour and a half or 90 minutes. So let's rewrite this. So I'm going to have X plus 1.02X plus 1.02 squared times X plus 1.02 cubed times X plus ... all the way up to 1.02 to the 12th times X. And this needs to be equal to 90. Now what I can do is this equation, each one of these terms shares an X. So I can factor an X out of here. And what I'd be left with is this coefficient is going to be 1. The next one's going to be 1.02 to the first power. The next one's going to be 1.02 to the second power, plus all the way up to 1.02 to the 12th power. And this is all going to be multiplied by X. And this needs to be equal to 90 minutes. So if I multiply, this large coefficient in front of X out, what I get is I get 13.412. I'm just going to say 13.41 multiplied by X is going to be equal to 90. I can take more digits, and actually when I do it in the, I'll just use this one. We're approximating anywhere. We're not even using 13.1, we're using 13. So then that means X is going to be equal to, 90 divided by this 13.41, which is going to give us 6.71. Now, we have to be careful with time because remember, time is broken into intervals of 60, not intervals of 100. So really what I need to know what 0.71 of the whole or of 60. So if you go 0.71 times 60, you're going to get 42.6. So we'll just say 43 to round to the second. So if I make 60 the whole as opposed to 100, this is going to be, 6 minutes. And then 43 seconds needs to be your beginning pace. If you like the content, please subscribe.